Hey, how's it going? It's Mr. Riley. I wanted to go over a few kind of key parts of the notes. This is the 1-4 Introduction to Angle Notes, and we are going to be going over some of the more important parts of it that I think y'all probably would need a little extra help on. So hopefully these are helpful. Here we go. So down here I've got an angle, this example number 1, and we're going to talk about how to label this angle and just come up with different ways that we can classify this angle so that you're not confused whenever we get to problems like this on, say, quizzes and tests. So first off, name the vertex of the angle. The vertex is like that corner. It's where those two rays come together. So our vertex is point K. The sides of the angles are the rays that come from that. Now, you always start the name of your ray with like where it starts. So I have a ray that goes from K through L, and you can see that I put this little symbol up here. So it starts at K and it goes through L, and I've got one that starts at K and goes through J. So you always start off with kind of like your endpoint, and then you go towards, and then you list out the point that ray passes through. So I've got KL, and I also have KJ, again with that symbol above it, that arrow indicating that it starts at K and it goes through J. Two ways to name this angle. We do have a few different ways. Whenever you talk about angles, you're always going to want to have that angle symbol, and then the naming of the angle goes to the vertex and then through it. So I could go J, K, L. That vertex is going to be in the middle, J, K, L. Or, again with that angle symbol, I can go the other way, L, K, J. But the main thing here is that the vertex is in the middle. So whenever you're reading angles, know that the vertex is the middle number there, or middle letter there. So J, K, L, I can look at that and ignore everything else and know that K is my vertex. Same with this one. Finally, classify the angle. This is where we're interested in, is it acute, obtuse, right, straight? This is larger than 90 degrees. You know, if I were to kind of draw a 90-degree angle, it would probably be about right here. This angle JKL is definitely larger than 90 degrees, so we are going to call this obtuse. Okay, so that's kind of like a label things. Of course, it could be more complicated. We worked through a problem, say, like this in class, where you have to do a whole bunch of different labeling and things like that. Main thing to pay attention to, how those names are written. Again, FBC means you go from F to B to C. B is your vertex. Rays are written with that endpoint and then towards the arrow. So B, E starts at B, goes to E, etc., etc. All right. Now let's go through one of these angle addition postulates and talk about how we can make sure we get these correct whenever we're working on them. Whenever we did segment addition, this is definitely something that was kind of difficult for some. So let's go through this problem and make sure we understand what is going on. So first off, if measure of angle ABF is 6x plus 26. So let's find ABF. ABF. This angle right here is 6x plus 26. So I'm going to put a line here. This indicates that angle. Notice what that line does. It goes from this ray, BA, to this ray, BF, ABF. All right, and I'm going to label it 6x plus 26. All right, and EBF is 2x minus 9. So I'm going to label this as 2x minus 9. And ABE, A to B to E, so this is a bigger angle, is 11x minus 31. Find ABF. All right, so here's the deal. Just like with segment addition postulate, if you have two angles that are smaller and they combine to make up a larger angle, add them together and they equal the larger one. So I have a smaller angle at 6x, let's keep the same colors here, 6x plus 26. That's this small one here, ABF. And then I have another small angle, an even smaller angle, 2x minus 9. We can add those two together those are going to equal the larger angle that includes both of them, right? ABE includes 6x plus 26 and 2x minus 9. So those are going to add together to equal 11x minus 31. And here's that same kind of procedure where we're going to use this equation to find x, and then we are going to plug it back in to find that actual measure of ABF. So let's find x right now. This is going to involve doing things like combining like terms. So 6x and 2x becomes 8x. 26 minus 9 is going to be 17. And this equals 11x minus 31 as we have the announcements going over me.
Please make your way to the library. Also, at the bell, club leaders are dismissed to set up their booths at the upstairs.
Again, I'm going to set this up algebraically, have all the x's on one side, all the constants on the other. So I'm going to subtract 8x so that over here I have 0, and over on the right side I've got 11 minus 8, which is 3, so 3x. And then I'm going to add 31 again on this side. Negative 31 plus 31 is going to cancel out. 17 plus 31 is 48. I'm going to divide both sides by 3. And I do believe that equals 16. Okay, so I've got 16 equals not 3, 16 equals x. And now the question wasn't what does x equal, the question is what does ABF equal? And if you go back into the problem, we can see that ABF is 6x plus 26. Well, we know, let's actually write this whole thing out, the measure of angle ABF equals 6x plus 26. Well, we know that x is 16, so we can rewrite this as 6 times 16 plus 26. 6 times 16 is a number that I'm going to find a calculator right now to figure out. 96. And finally, the measure of angle ABF is 96 plus 26, which is 122 degrees. That's your final answer right there. Okay, I hope that was helpful. Obviously, come into tutoring if you have any questions. I'll see you at tutoring, or I'll see you in class.